All right, so here's a spot for you just to take a little bit of notes to add, but I want to describe formally how are we going to find these horizontal asymptotes, this end behavior. It's going to boil down to something called the dominant division. So if you have a rational function, so you got a polynomial on the top, polynomial on the bottom, the end behavior of y is given or determined by a division. It's a division of the leading term. It's just the leader on the top and it's just the leader on the bottom that decides how y will behave. So this division, sometimes we call it the dominant division, where we're dividing the leading terms. Let's do some examples of this so you can see what I mean. Here I have a collection of polynomials. And so I want to find the horizontal asymptote. I don't want red here. I'm going to take red out. The horizontal asymptote is an equation of a line. It's y equals something. Now, the long logic behind all of this is as x goes to infinity, then where is y going? Well, in your mind, just remember that's what we're thinking. We're thinking as x gets really big, what is that going to do to the math when I try to get my y answer? So here's the shortcut. And I'm not writing in equals here, but I'm writing y is going to go to the answer. And the answer comes from this leader, x over this leader, 3x squared, which is basically x over 3. Oops, no, my bad. The x's are going to cancel, so I'm going to have 1 over 3x. So x is a million, a billion, a trillion. It's really big. 1 over a big number is going to equal a small number. Hold on. We're going to look at both vertical and horizontal, but I'm producing other videos while I'm recording this one. Sorry, I had a little extra sound from my other computer. So this is something we're going to kind of formalize, but I hope you'll catch on to this idea that if you have 1 divided by 10, you get 0.1. If you have 1 divided by 100, you get 0.01. 1 divided by 1,000, you get 0.001. The bigger this is, the smaller this is. So if we keep doing that, this is eventually going to go to 0. And that's what we're going to say is the limit. That's the calculation. That's what's going to happen. So this is going to equal 0. So the horizontal asymptote is equal to 0. So all you need to do is get this dominant division set up in your mind, or write it down, and then figure out what's the outcome of that division. It's 0. Here's another one. We want the horizontal asymptote equation. Y equals question mark. And we can get it by the dominant divisions. Y is going to behave, y's final answer is determined by the behavior of that division. Well, wait, what's x squared divided by x squared? They cancel. Y is going to end up becoming 5. And so when x is really, really big, these numbers don't do anything. And this takes over, and the final answer is 5. So the tails are going to be at 5. I'm not asking you to draw this, but 1, 2, 3, 4, 5. 6, 7, 8. So something is happening here. And the function is going to have some tail behavior. I don't know what the branches are going to look like, but they're going to come towards this boundary of 5. And there's a lot more to these branches. I'm just showing you the tail behaviors around 5 here. I know I'm going fast. Here's one more example. I want the horizontal asymptote. Well, it's going to be an equation, question mark, y equals something. And so it's going to be defined by the leader here and the leader here, and this becomes 2x. Now, as x goes big, 2 times a big number is bigger. This is going to go eventually to infinity. So here we're not actually able to write an equation because y is going to infinity. Now, a little caveat to our conversation. Rational functions have horizontal asymptotes that go to constants like 0 or 5, and occasionally they have end-tail behavior that goes to infinity, and that's not really a horizontal asymptote. It's called a slant asymptote. And so just to kind of tone this down a little bit, we're not going to really explore examples with slant asymptotes. So this is not one you have to master. But let's kind of simplify this whole thing. What's happening? There's some patterns here. Like this one, we had the first one. We had 1 over 3x. So we had a power of x on the bottom and just a number on the top. So if there's x's on the bottom and just a number on the top, and x gets really big, like this one, it went to 0. That's called the bottom heavy because all the x's are on the bottom and no x's are on the top. Sometimes the division is balanced out. Like this one, we had x squared on top, x squared on the bottom. So here, if the powers are the same, x squared and x squared, the x's are going to cancel out, and all you're going to have left is the a number. So this cancels itself with that. And so in that case, as x gets really big, then y is going to become whatever the coefficient is, a. That's called balanced because the x powers on top balance out the x powers on the bottom. Lastly, what we have is top heavy. So if I cancel these x's with some of these x's, I'm going to have x to a power left on top. And I'm going to have 1 on the bottom. So this one's called top heavy because I have more factors of x on top. And if I've got factors of x on top and I raise that to an infinity power, it's going to get really big. So I wanted to expose you to that. The top heavy one is what creates something called a slant asymptote. And we're not going to study that one too much. It may pop up in 1 or 2 questions, but mainly I want you to get really good at understanding asymptotes that are horizontal. These are our 2 horizontal asymptote definers, these 2 here.